Given a graph that's already labeled, we're going to identify the parts of it. This specific graph represents the function f of x is equal to x cubed minus 3x squared plus 6. So the directions are asking for us to find the following. So I'm going to name the graph based off of the degree and number of terms. The degree, the highest degree is 3, which represents cubic. And the number of terms is 1, 2, 3 terms. So that means trinomial. I could also call it a polynomial because poly means many. So cubic trinomial is the name of this specific graph. The next item is to list zeros, roots, or x-intercepts. That means the same thing. So x-intercepts basically where your graph is intercepting the x-axis. So this is the x-axis. I clearly see 3 points. Sometimes you won't see all of your zeros or x-intercepts on the x-axis because they may be non-real numbers. These just happen to be real numbers. So x is going to be identified by every point that has a y that is 0. So if the labels aren't clear and it's like really cluttered, that's how you can tell. You look for any y value that's 0. Those are your x-intercepts or zeros or roots. So we have a negative 0.732. We have 1. And our last x-intercept is 2.732. Those are all of my x values that will result in y being a 0. My local or absolute maximum, minimum. So maximum and minimum means the highest and lowest points of the graph. So absolute is like the absolute highest or the absolute lowest. It can also be the same as the local. In this case, it's both. So local is like if there's more than one maximum, the one that's not the absolute highest. Another word that you will see for local is relative. So the highest point on this graph, and again, maximum and minimum means going up or down. So that's representative by your y values on your y-axis. So for this one, my absolute maximum is going to be the value where y equals 2. My absolute minimum, when I look at where it's the lowest part of my graph, is going to be where y is negative 2. So it depends on your teacher. They may want you to actually put both, the entire set of the coordinates. I just want the y values. In behavior is asking what's happening with your graph when x is doing something. So what I would normally do is I would identify that going to the left on the x-axis, if I just keep going, I'm going on continuously. So that's negative infinity. If I'm going to the right, that's going to be positive infinity. It's the same for your y-axis. Starting from the bottom, it's negative infinity, and then going all the way up, it's positive infinity. And the reason this is important to label on your graph is so when you're talking about your end behavior, you can kind of see what's going on. As x is approaching negative infinity, what's going on with my graph when it comes to y? So again, y means up and down. My graph is going down. It's going down towards negative infinity. So that's what goes here. And then you ask, well, what happens when x is approaching positive infinity? What's going on with my graph in terms of y? My graph is going up towards positive infinity. So that's what it means when it's asking about end behavior. So now you may see something also that's referring to the intervals of increasing and decreasing. You're focusing on your x values. And again, we're going from left to right, negative infinity to positive infinity, but we're talking about what is going on with this graph, the intervals of increasing and decreasing. So for my first x value, I'm going to go to the highest point. So it increased all the way up to 0. So it went from negative infinity, and then it went up to 0, which is my x value. So I went up 0. Now it's also asking for decreasing. So from this point, I go all the way to the bottom. I don't just stop at point to point to point. So I'm going all the way to the highest point for x, all the way to the lowest point for x. This time it's at 2. So what just happened in between 0 and 2? I went down. Okay, so now at 2, what am I doing? I'm now going up. And again, I don't stop at a point. I just keep going until I get to the highest point. Well, I never get to a highest point. I'm going on and on and on and on to positive infinity. So the way I would write this is I would say that I increased from negative infinity to 0. And then I decreased from, and then your teacher may also want you to use like set notation. In this instance, I'm going to use just parentheses, but I decreased from 0 to 2. So, and that was representative here. And again, from 2 to infinity, I also have to take into account that what happened there. So I was increasing again. And here you want to put what's called a union sign. And you're going to say from 2 to positive infinity. You can either put a plus sign in front of it, or you can just put the infinity sign. But when you're talking negative, you definitely have to put that negative sign in front of it. So that's what happened with my increasing. I had two things happen because I have two arrows, and that will be easy to forget. So make sure that you're keeping track of your up and down arrows, and you should have 1, 2, 3 things going on when you list it. 1, 2, 3. In terms of domain and range, domain represents all of the x values that can be found with this graph. So this graph, again, is continuous, meaning that it's going to keep going down forever, but as it's going down, as you can see, it's also moving over to the left. And same thing here, as this one's going up, it's going all the way up to the right. So that means it's going to encompass all of the x values. So that's all real numbers. So for domain, we're going to say that it will encompass negative infinity to positive infinity. For your range, you're asking yourself, are there any restrictions as you're trying to go up on your graph? So going from the bottom, I go up, go down, but then I can keep going. So from my arrow, so there's an arrow here and there's an arrow here. So on my y-axis, I can keep going down, 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 down forever. And then the same here, I can go up, 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 up forever. So again, that means that it goes from negative infinity to positive infinity. So that's my domain and range. And it will always be this whenever your degree is an odd degree. So symmetry. You can either have even, odd, or neither. And it's based off of your degrees. I'm sorry, your exponents. So if I have a mixture of odd and even numbers, then this graph is going to have a symmetry of neither. If it were all even degrees, then of course it would be even. If it were all odd degrees, it would be odd. So that's how you identify a cubic trinomial in this instance. Okay, here's one. And again, you name it based off of what's shown for your degree and the number of terms. So the name of this specific graph, the degree is 4. That's called quartic. And I have I have many terms. So it's a quartic polynomial. If it were just 2, it would be a binomial. If it were 3, like a few minutes ago, it's a trinomial. Polynomial means it can have many terms. Okay, again, listing my 0 roots or x-intercepts. And this one is labeled, but it's a lot of things going on. So what you want to look for is where your y values are 0. So, and zeros, roots, and x-intercepts are the x values. So my x value here is the set of negative 1.596. This one also has a 0 for the y value, negative 0.183. This one has 1.516, and 2.263. Again, I know that I'm supposed to have 4 zeros or 4 x-intercepts. They do not all have to be on this x-axis because some can be non-real. These just happen to be real numbers. Again, local and relative mean the same thing. And absolute means like the highest that the absolute max means the highest that the graph can go. Absolute min or minimum means the lowest that the graph goes. Absolute max in this graph is the highest that I can go. And again, maximum and minimum represents your y values. The highest that this graph goes is 4.02. So my absolute max. And again, some teachers want both coordinates. I just want the y value. Is where y is equal to 4.027. I have another maximum here. So this is the one that you would refer to as either local or relative. So it doesn't matter. You can just say local. And again, it's still a maximum and it's still using a y value. So y for this one is 1.029. And now if I'm looking for my minimum, well, I only have one, so it can be either local or absolute. We're just going to use absolute. So absolute minimum means the lowest point on the y-axis that my graph will go towards is, let's just absolute minimum this time. Y is equal to negative 2.618. All right, let's see what's going on with the end behavior. So again, the end behavior is asking what's happening when as x approaches either negative infinity or positive infinity. What's happening with this graph? So as x is going towards negative infinity, and this is positive infinity, what's going on with y? Well, y veers down. So y is going. Another way of saying saying y is f of x. So just make sure you understand that. So f of x and y are the same thing. So what's happening with f of x as x is going to negative infinity? It's also going to negative infinity. What's happening when x is going towards positive infinity? What's happening with f of x? Well, it's also going to negative infinity. So in this instance, both of the y's or f of x's are going towards negative infinity for my end behavior. If I want to, again, discuss the intervals of increasing or decreasing, I want to draw like a little number line that'll kind of help me organize my data. And I am referring to my x values, what's going on with my x values. So let me pull this down so I can see that. All right, so as I'm coming from negative infinity on the x, what happens to this graph? It goes up. So my x value at this point I'm increasing is, so I'm increasing between the points of negative infinity and negative 1.053. At this point, I start decreasing. So I'm decreasing between the points of 1.053 and 0.612. At 0.612, I start to increase again all the way up until I get to 1.941. Again, I'm looking at my x values. And then from that point, I decrease and I just keep going. And I'm looking at my x value. So don't get confused when you see that I am going down, but I am going down on my x value towards my positive infinity sign. So that's what that is. So you have to pay attention to which values you're using, if you're using your x, if you're using your y. and pay attention to the arrows that you're drawing. So from this point, I start going down, but I'm still on my x-axis going towards the positive direction. So when I'm writing this out, I say I am increasing. And again, I want to start with the parts that are increasing. So I'm just going to change the coloring so I won't get confused. So I am increasing from negative infinity and then to negative 1.053. I increase again, so I want to do what's called a union at 0.612, and I keep going up, up, up until I reach 1.941. At this point, I start to decrease. Well, not start to decrease. I want to show my parts where I decrease. So here, my first point will be negative 1.053. And I decrease all the way up until I get to 0.612. And my next decrease starts at 1.941. And it keeps decreasing all the way to positive infinity. So you notice I have 1, 2, 3, 4 things here. I have 1, 2, 3, 4 things here. You will also notice that I always have a negative infinity and I always have a positive infinity. So that has to be accounted for. And when you have the unions, you're going to see the numbers duplicating because they're continuing. All right, so there should be a 1 right there. Domain, when it looks, so your domain again is all of your x and your y values. If it is continuous in both directions, like to the left and to the right, that means this arrow, even though it's going down, is also moving to the left, which left and right means all of your x and y, all of your x values. So my domain is going to be all real numbers, which is negative infinity to positive infinity. When you are writing this, you always go from left to right. So you will never have positive infinity first. Always negative infinity to positive infinity. This represents my x-axis. My range, however, is represented by my y values. So it's going up and down. Since this graph is starting from the bottom, then my range is saying it's starting from negative infinity, but the highest point that I can go on here, because it's restricted, is going to be where my y is 4.027. It's restricted, so I'm going to use the notation that tells it has to end there. It can't go any further. And then finally, the same thing with the symmetry. I'm going to look at whether or not my exponents are all even, whether they're all odd, or if it's a mixture. In this case, it's a mixture, which means that symmetry is going to be neither. That was a lot to take in. Yeah, that was a lot to take in. So I hope that you were able to understand some of the concepts. You can always go back, rewind, pause, and do what you need to do to get a clearer understanding of it. Thank you for your time.